Question number 1. Samad saves $2.50 every day. For every $15 saved, his father will give him an additional $3. How much money will Samad save in 50 days? We know that for one day, it is $2.50. So for 50 days, he will then get 50 times 2.50, which is equal to, let me grab my calculator, 5 times 2.5, 50 times 2.5. This will give us $125. So for every $15 saved, his father will give him an additional $3. Every $15 saved is equal to 1 times $3, or just $3. So you could say number of $15 saved will be equal to 125 divided by 15. And this will give us 8, or if you round it, we just put 8. So additional money will then be 8 times $3. This will give us $24. That means the total will then be equal to 125 times, plus 24. And this will give us $149. So that's the answer, $149. Question number 2. Eric gives 1/4 of his income to his parents. When his income increased by 20%, his parents received $240 more. What is his income before the increase? So income given to parents is equal to 1/4 of 100%, which is equal to 25%. So the easiest way to do this is let his income be 100 units, right? Why is because whenever I teach students, they get confused of using percentage with percentage. So let's just use 100 units. So when his income increased by 20%, his parents received $240 more. So that means income increased by 20%, which means it's basically 100 units times 120%. Okay, because his new income is 20%. So this will then give us 120 units. So income increased, or say new income. So let us just put in new income and given to parents, which will be the same, 1 out of 4 times 120 units, and 1/4 of 120 will be 30 units. So the income, or I will say his parents received more, in this case is $240. Okay, and his parents received more in terms of units. Okay, so before it was 25 units, after it's 30 units. So that means 30 minus 25, and this will give us 5 units. So which means 5 units equal to 240. So what is his income before his increase? So we know that the income earlier is 100 units. So 100 units will then be equal to 100 divided by 5, which is 20, times 240. And this will give us $4,800. All right. Question number 3. In the figure, PQRS is a rectangle, RTUV is a rhombus, RTU is 122 degrees, and VRS is 256 degrees. Find QRT. So we know that this is a rectangle. So let's just mark out the right angle triangle. And the next thing is, in order for us to get, okay, so not right angle triangle, sorry, the right angle over here. So if we want to get the QRT, which is highlighted in red, we need to get this angle, right? This angle, which is TRS. So let us just write down over here, to get the angle QRT, we need to then have 90 minus angle TRS in green. To get angle TRS over here, we would then just get this angle, which is, let me put this in blue, which is angle VRT, or basically 360 minus angle VRT minus 256, which is this orange angle in orange. Sorry, the 256 is in orange, not the VRT. So how do we get VRT in blue? So angle VRT is basically, can you guess? Because RTUV is a, if I were to zoom it out, RTUV over here is a parallelogram, right? So this is a parallelogram. So that means we can just have 180 minus 122, which in this case is 58 degrees. The reason is adjacent angles in the rhombus adds to 180. So now we know angle VRT, which is in blue. Then we can get TRS, which is in green. So TRS over here will be equal to 360 minus 58 minus 256, which is in orange. And this will give us 46 degrees. Now we know that the angle TRS, or in green, is 46 degrees. Then we can find our angle QRT. So angle QRT, which is in red, is equal to 90 minus, so TRS is 46 degrees. And this will give us 44 degrees, which is the answer. Question number 4. The average of 4 different 2-digit numbers is 92. Of the 4 numbers, find the smallest possible number. So we know that the average of 4 numbers is 92. That means the total is 92 times 4, which is 368. So to get the smallest possible number, we need the other 3 numbers be the biggest possible number. So number, and they have to be different. So that means biggest 3-digit or different digit number would then be equal to 99, 98, and 97. So that means the smallest possible 2-digit number. I need to put the word 2-digit. So the smallest possible 2-digit number will then be the total in this case, which is 368 minus 99 minus 98 minus 97. And the answer is 74. There you go. So the answer is 74. Question 5a. The solid below is made up of 8 cubes. Draw the front view of the solid on the grid. So to draw the front view of the grid, the front view of this will look something like this. So let me just zoom it in so it's easier to see. Okay, so we have the bottom 1, okay, 1, and then we have 2 over here, of course the front view, and then we have 3. Okay, so 1, 2, 3. So this will be on top of the other 1, and this will be on top of the other 2. So it's 1, 1, 2, 2, and 3. So to draw this, it will look like this. 1, 2. So this is the bottom layer, 3, 1, 2, 3. And then the top layer will look like this. So that's the answer lah. It will look like this. Let's go to part B. So part B over here, the solid below is made up of 8 cubes. What is the maximum number of cubes that can be added to the solid without changing the front and side view? So we know the front view from the previous question, which is this. So the front view is this front view. So we always want to have this. Then we also want to have the side view. So let's see what the side view will look like. So the side view will be 1, 2, let me zoom it in. 1, 2, 3, and 4. Okay, so the base layer or the bottom layer is 4. And then what are the other 2? What are the top layer will look like? 2 over here and 4 over here. Okay, so let's draw the side view. So 1, 2, 3, 4. So we have 1, 2, 3 like this. And then we have one more, which is 4 like this. So the other 2 cubes is at 2 and 4. Okay, so let's put it up. Okay, so I'm just going to copy and paste. So at 2, and this will be at 4. So it looks something like this. Now, how many cubes can we add so that the front and side view does not change? So I have a cube over here that I can add into this. So let's see. With this cube, where can we place it first without changing the front and side view? So if you were to say, let's put it over here, does it change anything? The front view, does it stay the same? Yes, it does. Side view, does it stay the same? Yes, it does. Okay, so I'm going to put 1 over here. Yay. Okay, let's have another one. If we put over here, do you think we change the front view? Not really, stay the same. What about the side view? Does it change? Not really, stays the same. So we can add another one. 2, yes. Okay, let's move to the next layer somewhere here. Okay, I know this is a bit hard to add, but imagine there is a cube over here, right? Okay, actually can add. Okay, yes. So if I were to put it here, will it change anything? I mean the front view or the side view? That's not right. So that means we have 1, 2, and 3. Okay, what about the one that's going to be behind, which is over here? Will it change anything? No, right? Because the front view and the side view look the same. Okay, 4 and 4. So we have 1, 2, 3, and 4. Okay, so we have 4. Okay, the next one. Can we add on top over here? Let me add like this. Can we add on top? So for the front view, it doesn't change. But the side view, suddenly, if you add this, it will then become over here. Okay, so we don't want that. Okay, then I think we cannot put on top. What about here? On top of the one that we add. Can we do that? No, right? Because the side view will then be looking like this. So technically, we cannot add anything at this or at this spot over here in the side view. So what about the next one? What about here? Can we put it here? Yes, we can. Because the front view, we still be able to see. And the side view also, we are still able to look the same. Okay, so this means this is number 5. Right, what about if we were to put it here, the next one? If we put it here, the side view remains the same, but then the front view will suddenly have another block like this. So we don't want to change it, right? So we cannot have that. Okay, what about if we add it here, right? If we add behind number 5, can we do this? So the front view will not change, but then the side view has another block like this. Okay, so we don't want that. Same goes if we were to put the block on top of number 3. The front view will then have another block like this. The side view will also have another block. And then if you put on top of 4, then you see that the front view will have another block, but the side view remains the same. So in total, okay, we also want to add the ones that are behind. Okay, so I have a tool for us to explore a little bit. So in this case, at the front view over here, you can see that it is okay. So it's a bit slanted. Okay, so you can see that the front view is okay and the side view is okay as well. So the next thing is we can actually add at the behind. So the 3D model, if I were to put it behind here, so you see there are the other spaces over here that we can add. Okay, so in this case, I've added the 3 more blocks at the behind, which will look something like this. So you see the behind, I added 1. So this is 1, 2, and 3. Okay, so these 3 cubes behind. So then you see the front over here. If I were to zoom it in, nothing's changed. And the right view over here, nothing's changed. Or the side view has nothing changed. So in this case, we have a total of 8 cubes that we can add. So the answer is 8. So question 6a, the pie chart shows Isabel spent her money. The amount of money Isabel spent on transport is 2/5 of the amount she spends on food. What is the percentage of Isabel's money spent on food? So what we can write is for transport. So whenever you see this, transport is 2/5 of the amount spent on food. That means transport is equal to 2 units and food is equal to 5 units. Since we know transport is in percentage 24%, that means 2 units is 24%. Then what will be the percentage on Isabel's food? So the food over here is 5 units. So that means 1 unit is 24 divided by 2, which is equal to 12%. Then 5 units, which is food, will then be 5 times 12, which is equal to 60%. Okay, there you go. The answer is 60%. So part B, Isabel saved $90. How much money did she spend in total? So the amount of money Isabel saved is 25% of the money spent on transport. So that means 25% is equal to 1/4. So if we were to I would say change the sentence. The amount of money of Isabel saved is 1/4 of the amount she spent on transport. So that means saved in terms of percentage is equal to 1/4 times 24%, and this will give us 6%. Then we also know that Isabel saved in dollars $90. So that means 6% is equal to $90. 1% will be 90 divided by 6. This will give us 15. Let me double check with the calculator. Right, it's 15. So that means how much she spent in total? 100%, which is total spent. Actually, it's not 100%, but we can put total money. Okay, so I think that's where people might get, or students get careless, is that 100% is total money with savings. So that means it's basically 100 times 15, which is 1,500. So what the question one is, how much money did she spend in total? So that means total spent without savings, which is equal to, so let's figure out the percentage. For total spent without savings, so we know that she saved 6%. That means 100. No, actually we don't need to calculate the percentage. What am I talking about? So total spent without savings is basically 1,500 minus 90. And this will give us $1,410. There you go. So the answer is $1,410. Question 7. A rectangular tank measuring 80 centimeters by 60 centimeters by 50 centimeters was 2/3 full of water. Type A can fill the empty tank in 8 minutes. How long did it take to fill the tank completely? So that means the total volume of water is basically length times breadth times height, which in this case is 80 times 60 times 50, and this is equal to 240,000. So current water would then be 2/3 of, or times 240,000, and this will give us 1,000 or 160,000 centimeters cube. So remaining water would then be equal to 1/3 times 24 or 240,000, or you can minus also. This will give us 80,000. We also want to know what's the rate of tap A, which in this case is 240,000 divided by 8, and this will give us 30,000 centimeter cube per minute. So the time to fill the tank completely, it's basically the remaining 80,000, 1, 2, 3, divided by 30,000, okay, which is basically 8 divided by 3. And this is 2 out of 3 minutes. So the answer is 2/3 of a minute. Question 8a. Frank's mass is y kg. His mass is 1/3 of Gideon's mass. Henry is 4 kg lighter than Gideon. What is the total mass of 3 boys in terms of y? So Frank over here is y kg. Sorry, not 7, y kg. Then his mass is 1/3 of Gideon's mass. So Gideon's. So his mass is 1/3 of Gideon's mass, which means Gideon's is basically 3 times of Frank, which is basically 3 times y, which is 3y kg. Then Henry is 4 kg lighter than Gideon. So that means Henry is equal to Gideon without an s. So let me remove the s. Minus 4, which is equal to 3y minus 4. I'm going to put here bracket kg. So the total mass would then be equal to y plus 3y plus 3y minus 4. And that will equal to 7y minus 4 kg. So when it's an equation, you need to put a bracket. So that's the answer, 7y minus 4 kg. For part B, if Frank's mass is 28 kg, what is the difference between Frank's mass and Henry's mass? So we know that Frank is y kg. So Frank mass is 28 kg. That means y is equal to 28 kg. So difference Frank and Henry would then be equal to 3y minus 4 minus y. Okay, because Henry is 3y minus 4, and then we minus Frank. It's basically just Henry minus Frank. And this will be equal to 2y minus 4. So this is in terms of y. So difference in Frank and Henry in terms of kg will then be equal to 2 times 28 minus 4. This will give us 52 kg if I'm not wrong. So 2 times 28 minus 4, 52. So the answer is 52. Question 9a. In the square grid below, ABC is a triangle. Measure angle ACB. So ACB is this angle over here. So I have my handy dandy protractor. So first thing is we want to add a line to our angle. So just a line, something like this, okay, or perpendicular line on the C over here, cause ACB, right? So from here, we can just align this line to angle ACB. That looks something like this. And then we can just zoom out a bit. And you see that the line that hits angle ACB in red over here is 36. So the answer to this question is 36 degrees. So for part B, BC form one side of the trapezium BCDE. BC is parallel to DE and AB is equal to BE. DE is twice as long as BC. Complete the drawing of trapezium BCD. So in a sense, from this statement, BC is parallel to DE. So it will look something like this, right? BC is parallel to DE. But we don't know how long DE or what or where DE should be. So if you have your ruler, you can use your ruler to make the parallel lines as what we see over here. So the lines will, make up to look something like this. Okay, so the most important part is that DE is twice as long as BC. So how do we measure BC over here? So we will form a triangle that looks something like this. I'm going to put this in red as like this. Okay, so BC over here, the length of BC is just the direction of these two different horizontal and vertical one. Okay, so the base of this B over here is 1, 2, 3, 4. So this will be 4 boxes wide, and this will be 2 boxes tall. So I see over here. Okay, so that means DE over here would then be 2 times, right? Which means it's literally like this, 2 times. Okay, and then you have this long line that looks something like this. Okay, so we just need to make sure that the whole measurement is actually just 8. Oops, don't put like this. So it's 8 and 4. Okay, so it's twice as long, something like this. Okay, all right. So let's put this aside. So we also want to measure AB and BE. So AB and BE over here. AB, the length is 3 is to 4. So we just want to do the same. What we can do is we can just have the measurements. So this is not 4, sorry, this is 2 boxes wide. So what we can do is we can have 3 like this over here. And then we can start, or essentially BE will be over here. So I'm going to draw the line as what you see over here. So once you have drawn the BE line, okay, so 3 is to 2, something like this. Then, so the E is over here instead, like this. Then you can draw the whole, so let me just remove this whole thing. Okay, I won't remove it, but I'll just put it like this. Okay, then you can just measure from the 4 or 8 boxes wide, and then put the 4 boxes tall like this. Then you have a point over here, and that's where you draw the line like this. Once that's done, then you can draw another line from C to D to create this trapezium. So there you go. So this is how it should look like. Question 10a. A shop offered 120 t-shirts at a 20% discount during a 7-day sale. The line graph shows the number of t-shirts left unsold at the end of each day. On which day was the most number of t-shirts sold? So from here, if you were to visually look at it, the steepest line is where the most number of t-shirts are sold. So what is the steepest line over here? So the steepest line means that, okay, if you have a ruler like this, if it's a gentle slope, that means nothing changed, right? Which means, for example, if I have this line and this line, right? So this line and this line, that means if it was 60 before, so this is an example, and this is 60 after, that means there is literally 0 sales, right? Okay, so let me put a dot instead of an X, but yeah, I'm just exaggerating over here, right? So let me just put the dot here and the dot here. Okay, so now if I were to put this dot at, for example, 40, then the line will be something like this, right? 60 to 40, that means we've sold or minus 20 in this case. Okay, so from here, if I were to have the same example, but this time the slope will then be even further. So that means, steeper, which is 2 boxes steep like this. So from 60 to 20, that means we minus 40. Okay, so the steeper the slope, the more shirts we sold. So over here, which one did we sell the most? So you could see that the steeper slope is from day 3 to day 4 in this case over here, right? So that means which is the one that's being sold the most. So that means day 4 is being sold the most because before day 4 there is 860, and after day 4 or what this number t-shirts left unsold, that means it becomes less than 60 or less than 40. So that means the steepest slope is from day 3 to day 4. So that means day 4 sold the most t-shirts, since day 3 is 60, and day 4 is less than 20. So therefore, the answer to this is day 4. Day 4. So part B over here, what percentage of 120 t-shirts was sold in the first 5 days of the sale? Correct your answer in the nearest percent. So we need to look at day 5, in this case over here. So day 5, I'm just going to highlight in red. And then day 5, we have a left with 20 t-shirts. So, day 5, we have 20 t-shirts unsold. So we know that start of sale, we have a total of 120 t-shirts unsold. So that means total t-shirts sold, it's basically 120 minus 20. This gives us 100. So percentage sold is basically total or t-shirt sold divided by total t-shirt times 100%. In this case, is 100 divided by 120 times 100%, which in this case will be equal to 83.333 ... percent. And we need to correct our answers to the nearest percent, which will be 83%. In the figure, 5 squares are drawn within a rectangular piece of paper. The leftover part of the paper is shaded. The side of the square X measures 4 centimeters. What is the length of the side of square Y? Since everything here is a square except for this shaded part, that means over here, if we were to zoom it in, is that Y, or the Y over here, is the same square. Visually, you can literally see it, right? So since one side of Y is the same as the red rectangle, red square, that means the red square is the same as the square or y, square y, square y, square y, square y, square y, which also means that one side of square X is equal to 2 sides of square Y, which means square Y side is equal to half of square X side, which is basically half times 4, or 4 divided by 2. This will give us 2. So the answer is 2 centimeters. Right, pretty straightforward. Okay, for part B, the breadth of the leftover paper is 1.5 centimeters. what is the length of the rectangular piece of paper? So we know that this is 2 centimeters, and for for the side x over here, it is, in this case, 4. So that means this square over here is equal to 6. So we have 6 for this side of the square. Then, at the same time, we also know that this is 6. So this part is 6 as well. And we know that this part over here is 4. Since this is a square, that means this part, or this square over here, is 10. 10, 10, 10, 10. Okay, since this is a square, that means this is also 10. So the whole rectangular part, okay, but one more. So the breadth of the leftover paper is 1.5. So the breadth is the shorter side of things, which means this is 1.5. So that means the whole length, so length of the rectangular piece of paper is equal to 10 plus 6 plus 1.5. This will not 1.6, 1.5. This will give us 17.5. Then we also know the breadth is equal to 10, or breadth of the rectangular piece of paper, which is 10. So we have the length. Okay, I a bit too fast game, but 17.5 centimeters. You don't need the length, huh? I thought we are looking for the area. But yeah, 17.5 centimeters. So for part C, Paul cut out each of the 5 squares on a rectangular paper into 2 centimeter squares. He then used the 2 centimeter squares to form cubes. What is the greatest number of cubes Paul can make? So for the 1010 over here, he wants to cut out 4 centimeters cube, which I'm going to make it into like a dotted line like this, or maybe like this, small, right? So 4 centimeters, right? So that means in this case, this will be 4 by, sorry, 2, not 4. What am I thinking? So 2 and 2. So the cutout for this 10 centimeters cube over here. So let me just drag this down. We have 10 and we have 10. So this is what I learned from my student when he explains on how he does this kind of question, similar kind of question. So for example, we have 5 and 5. Okay, so some students might think, we can just have 5 times 5, which is 25. Then 4 times 4, sorry, 2 times 2, which is equal to 4. Then we have 25 divided by 4, which in this case is 6, something like this, right? For example, let's say this is 5 and 5. Okay, so the answer is 6. But if you were to cut out properly, that's what you see over here. 2 by 2 is like roughly half, like this, right? And then we have one more, like this, and we have one more. So we have an excess, right? So this is a bit exaggerated, it's not exactly, but this is wrong. Okay, this is totally wrong because the area of a shape is not liquid, which I think is a very good way to explain. It's not liquid, so it cannot use the others remaining spaces to form another square, in this case over here. So that's what I like about my students' explanation. So in this case, for the 10 by 10, I'm going to reduce this to just 10, this to 10. So that means this 2 by 2 over here will be definitely smaller. And we can literally cut out exactly, in this case, 5, right? So we have this. So in a way, it's pretty manual for the 10 by 10 square. So the equation to get the number of squares is basically, or 2 centimeter side squares is length, so bracket length divided by 2 times breadth divided by 2. With that said, for the 10 centimeter square, the number of 2 centimeter squares in the 10 centimeter square will then be equal to bracket length divided by 2 and breadth divided by 2 and multiply, which is 10 divided by 2 and breadth divided by 2 is also 10. And this will give us 25. So if you were to, count all the squares, it's 25. Then we can do the 6 centimeter square. So let's do for the 6 So we have the length 6 divided by 2, 6 divided by 2. Luckily, all of these are even numbers. So it's 9. So technically, we can do the same with the 4 and 2 as well. So this is the same, I would say. So the x plus y plus read square is also the same as the 6 centimeter square, which means they can have... Sorry, they're not the same. My bad. So we do the 4 first. So number 2 centimeter squares in the 4 centimeter square is 4 divided by 2, 4 divided by 2, which will give us 4. Then for square y plus read square, it's basically 2 centimeter squares. So total squares that we can create, 2 squares, not 2 centimeters, 2 squares. Okay, so 9, no, we have the 10. So we have 25 plus 25 plus 9 plus 4 plus 2, if I'm not wrong. Okay, and this will give us, let me use the calculator, 25 plus 9 plus 4 plus 2, 40. Okay, so 1 cube, how many faces? So if you know, this should be 6, because a dice has 6 faces. Okay, so that means if we have 40 faces, how many cubes can we get? 40 divided by 6. Let's use the calculator, and this will give us 6.6 dot 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 666. The devil. Then this, we will round this number to 6 cubes. There you go. So the answer is 6. Question 13a. In the figure, ABCD is a rhombus and ADF is a trapezium. AF is parallel to DE. Find angle X. So one thing that the image did not show is this equal lines over here, which is HB is equal to BA. So if we want to find angle X in red over here, okay, so what we're gonna do is, first is we want to highlight the rhombus, which is ABCD, which is a rhombus over here. So we know that this is a rhombus, and we know that this is angle X. So that means this part is also X as well. So if we want to find angle X, then we need to find this angle HBA over here. So angle X is equal to 180 minus angle HBA, which is in green. And we put square brackets in green, and we divide it by 2. So how do we not in green, in blue. So how do we then get angle HBA? To get angle HBA in blue, we need to get another angle, which is going to be this purple angle over here. The angle HBA is equal to 180 minus, this is angle DBA. So angle DBA, which is in purple. So how do we get this angle in purple or angle DBA? If you know about rhombuses, rhombus has equal lines as what you see over here. And the thing is that angle DBA is part of this triangle. And half a rhombus is basically an isosceles triangle. So that means half of a rhombus is 2 isosceles triangle in this case. So that means triangle A or BDA is an isosceles triangle. So to get angle DBA in purple, it's basically 180 minus, so we want to get this green angle, which is BAD. Angle BAD, and we need to divide it by 2. Therefore, can we get angle BAD, which is in green? So angle BAD is actually equal to angle BCD. This is because opposite angles in a rhombus are the same, which means angle BAD is 108 degrees. Since angle BAD is 108 degrees, that means we can get angle DAB, which is basically 180 minus 108 divided by 2, which in this case is 36 degrees. Since we know this DBA is 36 degrees, then we can get angle HBA, which is in blue, which will then be 180 minus 36, and this will give us 144 degrees. So now we know HBA is 104 degrees, which is this. Then we can get angle X. So angle X over here would then be 180 minus 104 divided by 2, and this will give us 18 degrees. So the answer here is 18 degrees. Let's move to part B. So for part B, we want to find angle Y, which in this case is over here. Then how do we do this? First thing is that we know that ADEF, so I'm going to highlight it in red, not in an arrow, but in red, it will look something like this. And the parallel lines of the trapezium is AF parallel to DE, which will look something like this. So from here, for angle Y, we can either have this angle, which is AFE. So angle Y is equal to 180 minus angle AFE, which is in green, or angle Y, it's basically 180 minus DFE, which is 21, minus angle FDE, which is in this case in yellow. So I would say the easier way to solve this is not using this second option, which is this AFE in green. So how do we get AFE or angle AFE? What we need another, I would say, angle is angle GFC. So angle AFE is equal to angle, so if I were to zoom in, 21 in blue plus angle GFC, which is in purple. So how do you find the purple angle GFC? Since GFC, or let's make it a little bit more obvious, AFD. So AFD over here, if I were to make it a little bit obvious, you could see that triangle AFD is over here. So angle AFD in purple. Then how do we then get the two angles? Which in this case for angle AFD, what we need is 180 minus angle FAD. I'm gonna put this in black like this. So FAD and angle FDA, which in this case is red. So to get the angle FDA over here, we know that this is part of a rhombus that is highlighted in red. So FDA is basically equal to 180 minus 108, and this will give us 72 degrees. That's what we see over here. So 72 degrees. Then after that, we will also have this black angle over here. So since this black angle over here is also part of the rhombus, that means this angle over here, which is, let me highlight it in light blue, okay, like this, is 108 degrees, which is angle BAD, right? BAD in blue is equal to angle BCD, which is 108 degrees, because opposite angles in a rhombus are the same. So with that, we can get angle FAD, which is in black, which is equal to 108 minus 33, and this will give us 75 degrees. Now we know these two angles, then we can get the purple angle that we're looking for. Okay, so the purple angle is basically 180 minus FAD in black, which is 75, minus FDA, which is 72, and this will give us 33 degrees, right? That's what we see over here. So since we know this purple angle is 33 degrees, then we can get the blue angle, not blue, I mean green angle, which in this case is 21 degrees in blue, plus AFD, which is in purple, which is 33, and this will give us 54 degrees. So now we know that AFE is in green is 54 degrees, then we can finally get Y, which in this case is Y is 180 minus angle AFE in green. So it's easier, so I just made it easier to see. So Y is basically 180 minus AFE, which is in green, which is 54 degrees over here, because it is adjacent angle in a trapezium, which in this case is 126 degrees. So there you go. The answer is 126 degrees. Question 14a. There were almond and chocolate cookies in the container. Mrs. Tan took out 35 almond cookies and 60% of the chocolate cookies. After that, the ratio of the number of almond cookies to the number of chocolate cookies in the container was 2:5. What fraction of chocolate cookies did Mrs. Tan take out from the container? Give your answer in the simplest form. Okay, so for this kind of question, when you have a before, which in this case is almond chocolate cookies in a container, what has changed? And then there is the after, which then became a ratio of 2:5. I will draw a table that looks something like this. Even though part A is a pretty straightforward question. So what fraction of the chocolate cookies did Mrs. Tan take out from the container? So in this case, it's just basically 60%, right? And then 60% will be equal to 60 out of 100. And if you were to simplify it, this would then be equal to 6 out of 10. Simplify it again. If you divide this by 2, this will be 3 out of 5. So the answer to this question will be 3 out of 5. So nothing hard about this, but I believe the next question or next part would be, so 14 part B, Mrs. Tan had 154 more chocolate cookies than almond cookies at first. How many almond and chocolate cookies were left in the container in the end? Okay, so how do we then, solve this? So we can look at the chocolate part first, where it says here minus 60%. So that means before there is a percentage, which is 100%. Since the before of the chocolate is 100%, that means the after will then be 100% minus 60%. And this case will then be equal to 40%. So we have, since chocolate was 60% taken out, that means at first there was 100% chocolate. So chocolate at first 100%, chocolate in the end is 40%. And we also know that chocolate in the end is also how many units? From the question, it is 5 units as well. So we're going to put here 5 units. So that means we know the chocolate at first, there is a number of units. 40% is equal to 5 units. Then 100%, which is chocolate at first, will then be equal to 5 divided by 40, right? Times 100. Which in this case is equal to 12.5 units. And yes, units can be in decimal place. So what about almond before? So since in the end, almond in units is equal to 2 units. So that means at first, almonds will then be equal to 2 units plus 35. So almonds that were taken out is equal to 35. So we just need to reverse it. So 2 units, not minus, plus 35. From the question, it says Mrs. Tan had 154 more chocolates than almonds cookies at first. So that means chocolate minus almond. So this chocolate at first minus almond at first is equal to 154. Do we know the chocolate at first? Yes, we know. Chocolate at first is 12.5 units and almond at first is 2 units plus 35. So that means 12.5 units minus bracket 2 units plus 35, very important, equals to 154. If you were to convert this, you could see that 2 units plus 35 will be minus 35, equal to 154. So common mistake is the 2 units plus 35 is not in brackets, and the plus 35 will, and another mistake is the plus 35 is not changed to minus 35. Okay, so 12.5 units minus 2 units will be 10.5 units minus 35 equal to 154. We add 35 on both sides. So that means this will be 10.5 units equal to 189. Then 1 unit would then be equal to 189 divided by 10.5. Use the calculator and this will become 18. So now we know that 1 unit is 18. Therefore, what is the almond and chocolate left? in units. So you can see from the table, it's basically 2 plus 5, which is 7 units. So 7 units, which is total cookies left, which is 7 times 18. And this will give us 1, 2, 6. Okay, there you go. So that's the answer for question 14b. Question 15a. Figure OABCD is formed by overlapping two similar quarter circles OAC and OBD. OA is equal to OB is equal to OC, which is equal to OD, which is equal to 10 centimeters. The area of the shaded part OBC is 30 centimeters square, and the perimeter of the shaded part of OBC is 26 centimeters. Find the area of figure OABCD. So in order for us to solve this question or to find the area of OA or this whole thing over here, we know that there are two overlapping quarter circles as what I'm highlighting over here. So this is one quarter circle. Then we also know that this OD is 10 centimeters. So if we can find this part over here, which is the quarter circle, and then we minus the OBC, which is this shaded part, then we can get this leftover part, which is this part over here in blue, which is in this case COD. And since they are overlapping, that means this part is also the same. So if we can find these two area of the unshaded part, then add 30 centimeters square, we can find the area of the figure of this whole thing over here. Okay, so to find one non-shaded part, we need to find one quarter circle minus 30 centimeters square. So one quarter circle, the area itself would then be equal to 1 quarter and then times pi times radius times radius. And we know the radius for this case over here, which in this case is 10. So we have 1 quarter times pi, which is 3.14 times radius, 10 times 10. And this will give us 78.5 for 1 quarter circle. So now we know this quarter circle is 78.5. Then the non-shaded part, or one non-shaded part, is equal to 1 quarter circle, which in this case is 78.5. And then we minus 30. And this will give us 58.5 centimeter square. So to get the area of figure OABCD, which is basically the two non-shaded part, right? Which in this case over here, plus 30 centimeters square, which is the shaded part, then we can just have 2 times 58.5 plus 30. And this will give us 100 and... Sorry, my calculation was wrong. 78.5 minus 30 is 48.5. My bad. Okay, so in this case, instead of 147, it will be 127 in this case over here. Okay, so that's the answer, 127 centimeter square. So 15 part B, we need to find the parameter of the figure OABCD. So same thing, we know that it is a quarter circle and this part over here is 26 centimeters. So that means we need to find this part, which is also in green. So I will say the non-shaded curved parameter, right? So we need to find this green part over here. So to get the parameter of the figure OACBD, we basically need to have, in this case, the green parts, right? Or the non-shaded part parameter, and then plus a couple of things, 26, and then add another non-shaded parameter, and then plus 10 and plus 10. Make sense? And then this will be equal to 2 non-shaded parts. So 2 times the non-shaded part parameter in green plus 46. So to get the non-shaded part parameter, we basically need to have 1 quarter circle parameter minus 26. So to get the 1 quarter circle parameter or quarter circle parameter, we basically just have 1 quarter times 2 times pi times radius. So in this case, the radius is 10 and the pi is 3.14. So radius will be 10 and this will equal to 15.7. So we know the quarter circle parameter. That means to get the non-shaded part parameter. Oh, sorry. This is not 26. The 26 is basically, I was thinking 15.7 minus 26, that's a wrong thing. So actually, this 26 is this whole thing over here, right? This purple thing over here is 26. So that means it looks like a pizza. 26, and we have 10 on each side. That's what we see over here. So for this case, the curved shaded part parameter is basically 26 minus 10 minus 10. This will give us 6. My bad on this. So this is 6. So that means this is 6 as well. Okay, so the calculation will have to adjust. Okay, so 15.7, which is the curved quarter circle parameter, minus 6 will then be equal to 9.7. So now we have the non-shaded part, which is 9.7 in green. That means we can just add together, which in this case is parameter of figure OABCD is basically 2 times of the non-shaded part in green plus 26. So 2 times 9.7 plus 26, and this will give us 45.4 centimeters. So there you go. So that's the answer, 45.4 centimeters. Question 16. At a bookshop, erasers are sold only in packs of 8 and pencils are sold only in packs of 5. Erasers are 8 for $2 and pencils are 5 for $3. Mr. Tan bought erasers and pencils for his company. He spent 1/3 of his money on erasers and the rest of his money on pencils. He bought 36 more erasers than pencils. How much did Mr. Tan spend altogether? Okay, so to solve this question, what we can do is, first we need to make sure that we understand this part. Mr. Tan he spent 1/3 of his money on erasers and the rest of his money in pencils over here. So that means in this case, we need to put in this part. Okay, he spent 1/3 of his money. So in terms of ratio, it will look something like this. Okay, erasers is 1. 1/3 means the total is 3 and pencils is 2. So what this means with the ratio is that if the erasers is like $2, okay, then guess what the pencil cost? So if the eraser is $2, pencil is $4. However, this is not correct because pencils is only in multiples of 3 because pencils is $3, right? So from here, we need to find the lowest common multiple of 2 and 3 because erasers are $2 and pencils are $3. And this is for erasers. Since pencils are 2 times of erasers, pencils are 2 times, yes, correct, erasers, which means this will be, in this case, $6. So if the erasers over here is $6, then can you guess what the pencils are? Okay, the pencils are $12 because it's just 2 times, okay? And since $12 can be divided by 3 and then $6 can be divided by 2. Right, so from here, we can calculate the number of erasers for $6. So erasers is $6 or erasers cost is dollars, or I would say in this way, we are creating one group which has $6 of erasers plus $12 of pencils. Now the thing is that we need to know the number of erasers. So the erasers are $2 for 8 erasers. Okay, from the picture and from the question. That means $6 is equal to 6 divided by 2 times 8, which is 24 erasers. Now with the pencils are $3 for 5. So $12 will then be equal to 12 divided by 3 times 5, which is 20 pencils. So one group over here has 24 erasers plus 20 pencils. One group cost will be equal to 6 plus $12. Okay, this is important. And for later on, and one group. So we are looking for difference as well. Okay, so one group difference in terms of erasers. Why? It's because he bought 36 more erasers than pencils. So let me just put it there. He bought 36 more erasers than pencils. So we know that there's 24 and 20. So 24 minus 20 is equal to 4. erasers. So 4 erasers more is equal to 1 group. 36 erasers more would then be equal to 36 divided by 4, which in this case is equal to 9 groups. So now we know the number of groups. So 9 groups cost. As we know, one group cost over here is 6 plus 12, which is $18. Then 9 group is just 9 times 18, and this is equal to $162. Okay, there you go. So that's the answer, 162. Question 17a. Anne filled some orange juice into large and small bottles. She filled 3/5 of the orange juice into 4 large bottles and 3/4 of the remaining orange juice into 9 small bottles. What fraction of the orange juice was filled into the 9 small bottles? So what I'm going to do is I'm going to draw a model. So she filled 3/5 of the orange juice into 4 large bottles. So 3/5, and then I'm going to draw this arrow. So 4 large bottles, and then 3/4 of the remaining orange juice into 9 small bottles. So it looks something like this. So the 9 small bottles is 3/4 of the remaining. So the remaining is 2 units. So the thing is that for this, we can actually split them up, because you could see that this is 1 and then this is 2. We split them up like this. Since we split this up, what fraction of the orange juice was filled in the 9 small bottles? So if we split all this up over here, then we can just count how many are the 9 small bottles, which in this case is 3 out of 10. Okay, so you can use the model way, which in this case will look something like this, or so you can use the model way, or you can put like this, right? 4 large bottles is equal to 3/5. So remaining is equal to 2 out of 5, which is 1 unit. Sorry, not 1 unit. 1 minus 3 over 5, which is equal to 2 over 5. So the 9 small bottles, so you see here, 3/4 of the remaining. So 3/4 of the remaining is equal to 3/4 times 2 over 5. So 3 over 4 of the remaining is 3 over 4 times 2 over 5, which in this case will be 3 out of 10. Or if you were to just multiply, right, 6 over 20, simplify it to 3 over 10. Okay, so that's how you do it. Okay, let's move on to part B. Okay, so for part B, after that she wanted to fill 1 large bottle with leftover orange juice but was short of 0.6 liters. Instead, she filled another 1 small bottle and had 0.8 liters of orange juice left in the end. How many liters of orange juice did Anne have at first? So what is the leftover? So the leftover is this thing over here. Okay, so we have leftover, which is in this case 1 unit. So since we know the leftover is 1 unit, leftover is 1 unit. Okay, so we also know that 9 small bottles. So in this case, let me just put the 1 unit over here. 1 unit. Everything here is 1 unit, 1 unit, 1 unit, and also 1 unit in this case, right? So we know that 3 units is equal to 9 small bottles. Then 1 unit is equal to 9 divided by 3, which is equal to 3 small bottles. Since leftover is the same, or okay, if not, I'll just put here. So instead, she filled another 1 small bottle and had 0.8 liters of orange juice left in the end. So that means the leftover is basically 1 small bottle plus 0.8 liters. So what that means is that 1 unit is equal to 1 small bottle plus 0.8 liters. And we also know that 1 unit is also 3 small bottles. So that means 3 small bottles is equal to 1 small bottle plus 0.8 liters. And then if we were to minus, this will become 2 small bottles is equal to 0.8 liters. And 1 small bottle is equal to 0.8 divided by 2, and this will give us 0.4 liters. So 3 small bottles will then be 3 times 0.4, which is 1.2 liters. And we also know that 3 small bottles, 1 unit is 3 small bottles. So that means 1 unit is equal to 1.2 liters. And what's the total number of units? Which in this case is, if you were to count, is 10 units. So 10 units will be orange juice at first. Will then be 10 times 1.2, and this will give us 12 liters. So there you go. So that's the answer, 12 liters. Alright, that's about it. If you like this video, give it a thumbs up. If you want more of this kind of video, subscribe down below and comment down what other things you want me to show you next. See you in the next one. Bye bye.